Welcome back to the course entitled Elementary Electrochemistry. So, in the previous lecture, we have discussed about how one can calculate the EMF of a cell from the half cell potentials, and we have discussed a few such cells and talked about how one can calculate the EMF of a cell. So, in today's lecture, we are going to try to solve a few problems related to those what we have learned in last few classes. So, the question number 1 is calculate the equilibrium constant of the reaction H2 plus Cl2 in equilibrium with 2 HCl if the EMF of the corresponding cell is 1.01 volt. Right? So, to solve this problem, what we need to do is we need to first write down the chemical reaction that is happening at this electrode, at this cell H2 plus Cl2 forming 2 HCl, which is given. So, here this H is getting oxidized, hydrogen is getting oxidized and chloride is getting reduced. So, if we write this reaction in the two half cell reactions, one can write it as half H2 getting oxidized to H plus electron and half Cl2 taking up one electron is getting reduced to Cl minus, and the overall reaction is half H2 plus half Cl2 giving you just HCl. Right? So, now we have two electrodes here. One is the electrode H plus and half H2. By convention, we assume this potential to be equal to 0, and the other electrode, which is E0 half Cl2 Cl minus, is taken from the literature value from a textbook is 1.35 volt. So, here we have this electrode is used as anode and this electrode is used as a cathode, right. So, then when you write E0 cell is nothing but E0 cathode minus E0 anode, which is equal to 1.36 volt, right. So, now what we know from our previous class, the Nernst equation, E0 is equal to RT by NF, and then when we convert it to using the T equal to 298 Kelvin, then this constant turns out to be 0.0591 by N log Ka, right. So then here instead of activity one can convert it into 1 by number of electron transfer is 1, one can write log Kc, and then you can calculate that log Kc is equal to E0 divided by 0.0591, which turns out to be equal to 23.0118. So one can easily calculate the value of Kc as 1.027 into 10 to the power 23. So that is the equilibrium constant for that particular reaction. You see, this value is given, it is the E cell, which is equal to 1.01 volt, and you can recall E cell is nothing but E0 cell minus RT by F ln. In this case, the activity of Cl minus will be here, right. So in this condition, this is the EMF, that is the EMF of the cell and not the E0 cell. So here we don't need to use this value at all. One has to use the E0 of the chlorine chloride electrode to calculate the equilibrium constant of this reaction. So now the question number 2. Evaluate the expression for E cell of the following cell. Cadmium solid is in equilibrium with cadmium 2 plus in aqueous medium, is in connection with Fe2 plus Fe3 plus in aqueous medium with platinum as electrode. And here this side is the positive electrode, this side is the negative electrode. Positive and left is negative. So the anode reaction is CD getting oxidized to CD2 plus 2 electrons, and the cathode reaction is two Fe2 plus plus 2 electrons, giving you 2 Fe3 plus. So we had to make 2 electron to balance that 2 electron. So when you write the overall reaction, then you can write it as CD plus 2 Fe2 plus is getting converted to CD2 plus 2 Fe3 plus, right? So we can write E cell as E0 cell minus RT by NF ln activity of CD2 plus into activity of Fe2 plus square divided by activity of CD into activity of Fe3 plus square. And now one can set activity of CD equal to 1 because it is pure metal. So one can write the E cell without the activity of CD. Right? See, on the other hand, one can write ECD is equal to E0 CD minus RT by 2F ln activity of CD2 plus. Similarly, Fe2 plus Fe3 plus as E0 Fe2 plus Fe3 plus minus RT by F 2F ln activity of Fe3 plus square divided by activity of Fe2 plus whole square. So one can easily write that E cell is equal to E CD minus E Fe2 plus Fe3 plus, which is again nothing but what we have obtained here. If you replace ECD by this equation and E ferrospheric by this equation and then you simplify, you will end up getting the difference of E0 CD minus E0 Fe2 plus Fe3 plus, which will be replaced by E0 cell minus RT by NF ln activity of CD2 plus into activity of Fe2 plus square divided by activity of Fe3 plus whole square, and this is replaced by E0 cell, right? So this is how one can derive the equations for the corresponding cells for a cell from the corresponding half cell potentials. Let us see the question number 3. Calculate the potentials of the following electrodes at 25° centigrade. So one is Ag plus with activity equal to 10 to the power minus 5. Number 2 Cu2 plus with activity equal to 0.2, and number 3 is platinum electrode in equilibrium with Fe2 plus of activity equal to 0.1 and Fe3 plus of activity equal to 0.01. So I will explain, or I will show you how to do it with the first one, and you should try to solve the other two. So the reaction is Ag going to Ag plus plus electron. So Ag plus is nothing but E0 Ag plus minus RT by F, because it is one electron transfer, ln activity of Ag plus. So now you take the value of this E0 Ag plus from the literature. We found it to be 0.799 volts minus 0.0591 ln, I think should be log 10 to the power minus 5, and the unit is the volt. So once you do this, you should get it as 0.119 volt. So this is the EMF of the half electrode with a given value of activity of silver. So similarly, you should try to do this and that using the standard values available in any standard electrochemistry textbook which are prescribed for this course. Now question number 4 is, construct the electrochemical cells for the following reactions and find their standard free energy change from their EMF. Once again, you need to find out these EMFs from any standard textbook, and I am giving you 3 of them. Will solve one of them. Half Cl2 plus Br minus is in equilibrium with half Br2 plus Cl minus. B is Hg2Cl2 is in equilibrium with 2Hg plus Cl2, and C is H2 plus Cu2 plus in equilibrium with Cu plus 2H plus aqueous, right. So let us try to solve A. So it is nothing but half Cl2 plus Br minus giving you half Br2 plus Cl minus. So here what we see, bromine is getting oxidized. So that means this is happening at anode, and chlorine is getting reduced. So this is happening at cathode. So as soon as we identify the corresponding cathode and anode, we quickly write down the possible cell with suitable electrode. So what we write is platinum is in equilibrium with bromine gas, and the solution contains Br minus in aqueous medium. It is in equilibrium with, or it is in contact with Cl minus with platinum with chlorine. Right. So, now what one can easily calculate here is E0 cell is nothing but E0 left minus E0 R, and when you try to find out those values from the textbook and do the math, you will get this to be plus 0.2938 volt. So, what we know is delta G0 is equal to minus NF E0, and this E0 is the E0 cell, which is this one. So, when you do that, you place the value of F as 96500 and N is a 1 electron transfer. One can easily calculate this number or the delta G to be minus 28.35 kilojoules. You see, one has to note that when we are writing kilo, that K is small, and when we write joule, it's the unit of energy, but then the unit comes from the name of a person. As a result, that J is capital. So, always whenever you are writing the unit, one has to remember how to write the unit correctly with proper capital or small letters. So, now I want to give you a couple more problems for you to solve at home. So, two problems to be solved at home are this the following. If the potential of the cell is ZnCl2 with molality 0.01 in connection with AgCl solid with Ag as electrode is 1.16 volts, then calculate the mean ionic activity of ZnCl2 solution. Question number 2 is, consider the cell given below. TL in connection with TLCl in solid form. It is in connection with KCl solution of molality 0.1, and the other end the electrode is Hg2Cl2 solid with mercury as your electrode. I think one should not write this slash, because slash indicates a phase boundary. One should write just comma. The value given is the E cell as 0.73 volt and dE dt equal to 7.5 into 10 to the power 4. So the question is, what is the cell reaction calculate delta G and delta H of this cell, right? And question number 3 is construct a suitable cell and calculate the E cell value for the following cell reaction. The reaction is indium 3 plus 2 indium getting converted to 3 indium plus. See here, what is happening is the same element indium is getting reduced and here it is getting oxidized. So you can understand that both the electrodes will have system of indiums. So one has to find out the electrode potential of different indium cations with indium 0 and indium cations and another indium cation and so on to do this problem. So you need to find out the standard electrode potentials for various indium related systems from a textbook. So here I leave these 3 problems for you to solve before the next class. Thank you.